Hello everyone, my name is Muhammad Rasyid, ID 101200073. Today I want to explain about my final project, that is exploration of Sendov Conjecture, trivial polynomials to sufficiently high degree polynomials. This is my presentation overview, consists of problem overview, motivation, methods, and references. Let's take a brief overview of calculus. Roots of polynomial f of x are value alpha, such as f of alpha equals to 0. And critical points of polynomial f of x are value beta, such as f prime of beta equals to 0, or the derivative of f of x equals to 0. We can ask general question, how are the zeros alpha and the critical points beta are related? So there are a theorem called Rolle's theorem from 1691. If all zeros of f of x are real, then between two adjacent zeros, there is a critical point. This is an example of roots and critical points of f of x equals to x minus 1 times x minus 2 times x minus 3. We can see that between zeros 1 and 2, there is a maxima points, and between zeros 2 and 3, there is a minima point. Both of them are critical points of f of x. We can ask other general question, such as how about the complex zeros, not the real one. So for complex zeros, there is a conjecture called Sendov Conjecture. Sendov Conjecture, sometimes known as Iliev conjecture, is a conjecture that concerns relationship between location of roots and critical points of monic complex polynomial function. It named after Blagovec-Hristov Sendov, proposed in 1959. So Sendov conjecture, given monic complex polynomial with n degree as follows. P of z equals to product of z minus zi, where modulus zi is equal or less than 1. We know that zi is the root of pz, and the derivation of the polynomial as follows. P prime of z equals to product of z minus lambda j. Then for every zi, there is at least one lambda j, that is modulus zi minus lambda j is equal or less than 1. So in simplified way, we know that given the polynomial p of z, for every roots, there is at least one critical point, that is distance between the roots and the critical points is equal or less than 1. Let's take an example. Given complex polynomial p of z with degree 2. So p of z equals to z minus z1 times z minus z2. In simplified way, z squared times minus z1 minus z2 times z plus z1 z2. We know that modulus z1 and modulus z2 is equal or less than 1. Then the derivative of pz, p prime of z is equal to 2z minus z1 minus z2. There is only one root for p prime of z, or one critical point for pz, that is lambda equals to z1 plus z2 divided by 2. Observe that modulus z1 minus lambda, or distance between z1 and lambda, is equal or less than 1. We can find it using normal calculation and using triangle inequality in this calculation. And then we can find that modulus z1 minus lambda, or distance between z1 and lambda, is equal or less than 1. We can also do that on z2 minus lambda, or distance between z2 and lambda, which is complete our Sendov conjecture for p of z with degree 2. This is the geometrical references. We can see that for z2 and z1, we know that maximum distance between z1 and z2 is 2 in the unit circle, and lambda acts as the mean point between z1 and z2. And we know that for the mean point, a distance between z2 and lambda is only 1, and distance between lambda and z1 is also 1. So that example covers for every complex polynomial degree 2. But how about higher degree polynomial, such as 3, 4, 5, 6, and more? That is my motivation to study about the Sendov conjecture. For now, Sendov conjecture already covers for 8 degree polynomial by Brown-Chiang and n degree sufficiently large by Terence Tao. The methods I use is understanding direct proof at trivial and special cases in Sendov conjecture, understanding Gauss-Lucas theorem, rotation transformation, and extreme polynomial in Sendov conjecture. And lastly, understanding the method used by Brown to prove Sendov conjecture at 6-degree polynomial. So this is my references. That is for now. Thank you for listening in my explanation. If you have any question, please send it through my email at the beginning.